Hello and welcome to Understanding Length of Stay using box plots with hopefully not too much tricky maths. With me, Simon Willis Miller, Information Manager for Devon Partnership Trust. And just to say, these box plots will work with waiting list too, and we'll look at that in a bit. So, understanding length of stay. Length of stay is a summary metric aimed to give us an idea of what's going on within our wards. Best explained by having a look at a very, very simple example. So we have our ward of patients, and each of them has its own individual length of stay. So there's 1 for 23, and finally 2 days. So let's chuck them into order, just make it a little bit more easier to see. And we are also going to bang Mr. 20, Bob over there, over to the far right hand side, just for a bit of an idea of scale. So let's do some maths. The most basic average is our mean, which is 1 plus 2 plus 3 plus 4 plus 20, which will be 30, and then divide that by 5 because there were 5 patients, which would give us our mean of 6. So the question is, looking at our patients and our distribution of the lengths of stay of all our patients in the ward there, is the answer 6 a good representation of those patients? So 80% of the patients are below 6 days, and 20% are way above those 6 days. So by using that mean, it is severely skewed by an outlier. So alternative is look at a different version of calculating average, which is the median, which I'm sure you could all remember from school, is the literal middle value of a data set. So we've already tidied our data and chucked it into order, which makes a little bit easier. And we can clearly see that our middle value in this instance is 3. So again, is 3 a better representation of our data set? It kind of sits more where our data lies, and it gives us a better feeling of the average of our data set. However, it completely fails to take into account outliers. So our 20 could be 200, could be 2000, and our average, our median, would still be 3. So what we need is a nice way where we can represent our data set, see where all that data lies, and also take into account and understand the extent of our outliers, and really, really fully see and visualize that full distribution of what's in our ward and what is going on. That way, like I say, we can have a look at the actual totality of our data. So what we're going to do is split it down a little bit further in order to describe it. So there's our patients again. And we already have our middle or our median value, which splits our data into half. So we're going to draw a very simple line there. Now we're going to take it one more step, and we're going to split our data into quarters. So literally the data point between the middle and the minimum is 2, and the data point between the middle and the maximum, which is 4. So the line between the middle and the median is called the first quartile, which is this one here. And the line between the median and maximum is called the third quartile, which is this line here. Don't worry, you need to remember that there is not a test. So just to make it clearer, we're going to put this section in a box. So by splitting it into quarters and taking 2 quarters, I'm sure hopefully you can work out that 2 quarters is a half. So that all that sits within that box is 50% of our data set. So as we said, we know that half our data lies within that section. So what we need to know now is how wide our range is across all of our patients. So this having that box allows us to help identify our statistical outliers. So like I said, we want to represent the spread of the distribution. So we've already calculated that. So what we want to do is calculate the range difference between our first and our third quartile. Sounds tricky, but basically we just want to know how wide is this section here, which is called the interquartile range. It's the range between the 2 quartiles. Again, not tricky maths. We're talking about quarter quartile 3 minus quartile 1, which is literally 4 minus 2, which gives us an answer of 2. So we draw a line to show the range coming from the box. So we draw a line up to 1.5 times our interquartile range. In this instance, 1.5 times 2 will give us an answer of 3. So we draw a line up to 3 coming from our box, out to the left and out to the right. So if the line reaches the maximum or minimum, we will just leave it there. We won't go sort of draw past it. We will just leave it there. So we will tidy that up and just show a simple line. Nearly there, but not quite. What we now have is a plot that shows us our average, which is our line 3, our middle line. But it also shows where the majority of our data lies, which is between sort of 2 and 4. So 50% of our data lies there. However, we do still have a data point that's not included. So poor old Bob there over to the far right is an outlier. And now we can actually see that statistically that patient is an outlier. It fits outside our normal expected distribution. So we mark this statistical outlier simply by plotting it as a dot on our chart. So we can see it like that. And each individual outlier, if we had more than one, each of those would be plotted as a singular dot. So removing all the underlying stuff, we're left with our box plot, which is looking like that. So this example, obviously not strictly to scale, but hopefully you get an idea. So technically, if a quartile line contains no data, then we don't plot it, we remove it. So we take that one off, and that's what a box plot should look like with the data that we had. So that was a little bit of a poor example, but just try to make it as simple as possible to understand. Of course, box plots can be vertical as well as horizontal, so it can look like this, which is possibly the more reasonable way of seeing things, but exactly the same principle, work on exactly the same data sets. And again, just a very quick reminder, we can have outliers either to the lower or outside the maximum. So you can have low outliers as well as large outliers. We've got our interquartile range again, which is where 50% of our data lies. So we can see that broadly that's where that fits. And then we have our lines which show our minimum and maximum expected values. So I know what you're thinking. Great. Still a little bit of maths there. Hopefully you can just have a look at those box plots and see what's going on there. So how can we use this to actually understand our actual laws? So here's an actual example using some actual real data looking at Deltafield and Moreland View. We can see that Deltafield has a slightly higher 56 days median length of stay, and Moreland View has a 51 median length of stay. So on our old school way, we would say that Deltafield had a slightly more average length of stay than Moreland View. However, there are obviously some more things going on than that. So what I will do, I will add in some individual dots so we can see all the individual patients as well. So bringing in the actual patients, which are these individual dots, just so we can see how that lies. We can see that Moreland Views obviously had a few more sort of more recent inpatients who have got a shorter length of stay, which have come through. But also there is a sort of wider spread here, and that we do have, say, a number of patients who are considerably more and over that 100 days. Deltafield, we are seeing that, okay, on average, there is a narrower split, and that the outliers are, the overall split is going up to about 110 days. However, we do see that there are some individual outliers here and here who are considerably more, have a considerably longer length of stay. And again, we can sort of obviously investigate and see what's going on there. So hopefully you can see that by using box plots, you can actually understand much better the full distribution of what's going on within wards. So we take every patient to account, and that we can actually see where we have got those outliers. We can see not only is the average going down, but is the longest the longest lengths of stay also coming down over time. So understanding LOS is hard. There are lots of different nuances. If you're in acute and you're in a arm breaking ward, and you have somebody with a broken arm, they come in, you sort of wrap your plaster around them, and they will get better in about 2 weeks. Occasionally, it might be sort of 10 days, and occasionally it might be sort of 20 days. But you kind of have a really narrow expected length of stay. With mental health, that's certainly not the case, and we do have significant outliers for sort of various different reasons, especially patients who might be sort of stepping down from other services or being transferred from one service to another. So understanding that sort of full totality of length of stay is really important, and we must sort of kind of keep track of all of our patients. So that is the end of my talk. Hopefully that's enough to get you all started on understanding how those box plots works. Obviously, any issues or any problems, then do get in touch with your local and friendly analyst, who will be able to explain further with possibly more examples. Thank you very much.